Good morning, students. In last class, first session of mechanism of breathing, I discussed about the normal pressures, the three pressures at rest. That is intraalveolar pressure 0, intrapleural pressure -5, atmospheric pressure 0. Hope you remember. Intraalveolar pressure 0, intrapleural pressure -5, and we all know why intrapleural pressure is negative at rest. Atmospheric pressure is 0. So these three pressures at rest we discussed in the last class. In today's video, I will be discussing what will happen to these three pressures during inspiration and what happens to these pressures during expiration. So before going into the change in the pressures during inspiration and expiration, I will explain about the process of inspiration and expiration. So please note it down. Mostly you all know inspiration is an active process, that is it requires energy and muscles are needed to contract to cause inspiration. So inspiration, just I will explain. So inspiration is an active process. So the main muscles involved are diaphragm and external intercostal muscles. Just imagine, I will explain it like this. I am not having the skeleton now. So this is our lung, and below the lung you are having the diaphragm like this. So just to see a concentrator, otherwise I can try to draw. So this might be the diaphragm. Yeah, this will be the diaphragm. So what happens? For example, I am doing normal inspiration. We all know when I normally inspire, 500 ml of air is going to come in. So for this inspiration to occur, this -5 intrapleural pressure alone is not enough, because at rest only this intrapleural pressure is -5, but still I require more negativity. So what happens? This diaphragm contracts. So now I think you can understand. So what will happen when the diaphragm contracts? It is pulling the lung downwards. To make it simple, I will make it simple. When the diaphragm contracts, the lung is pulled downward because of the contraction of diaphragm, and vertical diameter is increased. Simple. So increased vertical diameter, very simple. So see, before contraction of diaphragm, this is the lung. As the diaphragm contracts, this is the lung. So the vertical diameter is increased. From up top to bottom, the length of the lung is increased. So that is the role of diaphragm. Now another muscle, very important muscle, external intercostal muscles. For this little bit anatomy we have to understand. I will just try to explain again. Imagine this is one rib, this is another rib. For understanding what happens, external intercostal muscles origin, the origin of external intercostal muscle is from the above rib, and it is inserted into the lower rib. Again, you have to imagine the skeleton, imagine the sternum, sideways ribs are there. Imagine like this. Yeah, these two ribs are here. Yeah, these two ribs are here, and these two ribs will be there. And imagine this is the external intercostal muscle, and see here. So this external intercostal muscle origin is from the above rib, and this is inserted into the lower rib. Imagine my finger as external intercostal muscle. So the origin is from the above rib, and it is inserted into the lower rib. Now when the external intercostal muscle contracts, what happens? This will pull the lower rib because it is inserted into the lower rib. For example, this is the external intercostal muscle. This is inserted here. When it contracts, what will happen? Just understand. So this is one rib. This is one rib, upper rib, lower rib, and the external intercostal muscle is from the origin is from the above rib, and insertion is into the lower rib. Yeah, now see here. Okay, yeah. Now when this contracts, what happens here? See the movement. Now it is like this. This is the external intercostal muscle. This is contracting. As this external intercostal muscle contracts, yeah, this is pulling the rib outwards. Otherwise, so I'll just make it simple again. That it is. So this is before contraction of the external intercostal muscle. This is contraction of external intercostal muscle. So as the external intercostal muscle contracts, it is inserted in the lower lip. So this lower lip moves outwards. That's what I want to tell. The lower lip moves outwards. So what will happen? Yeah, like this. So from the lungs. So imagine this is the lungs, and the surrounding the rib cage, it is moving outwards like this. So what happens? It is moving downwards. So the transverse diameter is increased. So because of contraction of diaphragm, vertical diameter is increased. Because of contraction of external intercostal muscle, the rib is pulling. The external intercostal muscle is pulling the rib outwards and away. So transverse diameter is increased. Okay, any idea? Do you remember the movement which I make? You might have read some type of movement during mechanics of breathing, especially during inspiration. Yeah, you try to understand. Like this. The external intercostal muscle contracts, the rib is moving away and outwards. Like this. You can even pause the video and try to answer what movement is this, what I am making. Like this, I am lifting and closing. Lifting and closing like this. This movement like this. Whatever I make because of external intercostal muscle. Some handle movement. Yeah, two handle movements are there, but what is this? Increasing the transverse diameter. Yeah, it is bucket handle movement. So note it down. Bucket handle movement is a movement which is occurring during inspiration, especially because of contraction of external intercostal muscle. So a better way to draw, it's easy. So this is one rib, this is another rib, upper rib, lower rib, and this is external intercostal muscle. So when this contracts, what happens? This is going like this. This is what I am explaining. So when the external intercostal muscle contracts, this is inserted into this lower part, lower rib, in fact, upper part of the lower rib. Origin is from the upper rib. So what happens when this external intercostal muscle contracts? It pulls this. So this rib is moving downwards and outwards. As it moving outwards, the bucket handle movement is created and transverse diameter is increased. I have written it increases transverse diameter, and of course, not only this movement like this is also space is created. That is because of the contraction of external intercostal muscle, the front and the back. The front is sternum and back is vertebra, and this is also the space is otherwise AP diameter. Increased AP diameter, anteroposterior diameter is also increased. That the same mechanism like this. For example, this we call it as pump handle movement. Pump handle movement. It is like moving like this and coming down. So pump, I am pumping. So like this. So antero-posterior diameter. So diaphragm contraction, vertical diameter, external intercostal muscle, bucket handle movement, transverse diameter, pump handle movement, antero-posterior diameter. So all the three diameters are increased. Otherwise lung is expanded during inspiration. And inspiration is an active process. Mainly two muscles. This is even for normal inspiration. Now, for example, I am just normal inspiring. 500 ml is going in. All these muscles contract and all these diameters are increased. Very simple. And I already told you in last video, at rest 0 is the intraalveolar pressure, -5 is intrapleural pressure, IAP, intraalveolar pressure, -5 is intrapleural pressure, again 0 is atmospheric pressure. Now I told what happens during inspiration. Yeah, before going into the pressures, I will finish expiration also. Expiration, no muscles involved, it is a passive process. So no muscles involved, just elastic recoil of the lungs. We all know property, one of the main property of lung is it loves to recoil. So as the 500 ml is going in, I will explain the pressure changes. And once inspiration is over, the lungs automatically recoils. Yeah, the diaphragm relaxes, maybe external intercostal muscle relaxes, all the muscles of inspiration relaxes and lungs compresses back to normal or tries to recoil. So note it down, expiration is a passive process. Yeah, now let me enter into the pressure changes during inspiration. So I finished muscles of inspiration, muscles of expiration, and there are two movements. Now we have to think. I am inspiring. So during inspiration, what happened? Yeah, this is little bit going down. I will put the arrow mark. Now you have to little bit concentrate. I will just draw here alone. Now I am going to draw inspiration. I am not going to draw fully, just this area I am exposing. Yeah, inspiration. Yeah, during inspiration, yeah, this is also increased. The entire thing I am just showing you a small part, inspiration. So during inspiration, the lung volume is increased, vertical diameter is increased, Transverse diameter is increased. Antero-posterior diameter is also increased during inspiration. Yeah. Now what happens to the volume during inspiration? Obviously, volume is increased. So the volume of the thorax is increased, or the volume of the pleural cavity is also increased. Now as the volume increased, again bring back the Boyle's law. We all know in the Boyle's law, volume and pressure is inversely proportional, or whenever volume increases, pressure decreases. So this is at rest. So let this side be rest, this side I am putting inspiration so that you can understand. Yeah, inspiration, this is rest. Yeah, intrapleural pressure is -5, alveolar pressure is 0. Now what happens? The volume is increased because of contraction of diaphragm, contraction of external intercostal muscles. As the volume increases, what happens to the pressure? Yeah, the intrapleural pressure decreases as the volume increases, Boyle's law. So during inspiration, it may even become -6 to -8 millimeter mercury. So I keep it -6. So from -5, the pressure has decreased. So add one more -1, it is -6. Now this pressure creates a suction. So -5 was not enough. But now because of inspiration, because of this increase in the volume, the pressure has decreased. The same thing applies for intraalveolar pressure. So instead of 0, I will mark it here inspiration. Yeah, inspiration, it becomes -1. So why intraalveolar pressure is negative? Because intrapleural pressure is from -5, it has become to -6, which causes intraalveolar pressure also to decrease because they are interrelated. So intraalveolar pressure is becoming -1. Now again, I can understand some students confuse. Okay, sir, I understood intrapleural pressure at rest -5. Why it became more negative -6? This volume is increased. Now understand here, this intrapleural pressure is now -6. -1 is added or more negative. So what will happen to the alveoli? You can pause the video and answer. As intrapleural pressure is more negative, I will give the option. As intrapleural pressure becomes during inspiration more negative, what will happen to the alveoli? It will collapse, it will expand. You pause the video and answer. If you answer this, the next step will be easy. Yeah, very good. As the intrapleural pressure decreases, it expands the alveoli. Already told at rest why the alveoli is not collapsing. Very, very important. During rest, I am not inspiring, not expiring. Lung is at rest. But still, the alveoli is maintained at its position and it is not collapsed. The reason is this negative pressure maintains the alveoli apart from the surface tension, all those things. So now the pressure is still decreased. So what will happen to this alveoli? Yes, this will expand a little bit what I am drawing. Or this, let this side be the same, but this side inspiration I am showing. So it is expanding. So note it down. Alveoli expand. Why alveoli expand? Because here the intrapleural pressure from -5 has become -6. So because of this alveoli is expand. Obviously, when alveoli expanded, what will happen to volume? The alveolar space is more. So as the alveolar space is more, pressure decreases. Again, Boyle's law. Volume and pressure are inversely proportional. So as the volume is increased, pressure is decreased. Note it down. Pressure is decreased. Now we all know gases move from, what is that law of diffusion? Gases move from high pressure to low pressure. So we all know outside pressure is 1 atmosphere, which is 760 millimeter mercury. But here it was actually 0. I mean at rest. 0 means with respect to atmosphere. But now what happened? It is -1. If you want to write in actual value, it will be 759. So now what happens? Outside it is 760. During inspiration, it has become -1. All the things we explained why it has become -1. That intraalveolar pressure, why it is negative. So now what happens? From 760 it will go to 759, or there will be no flow of air, or vice versa. Obviously the air comes in from high pressure to low pressure. Simple. So inspiration is, this is how it happens, from high pressure to low pressure. Why low pressure? Volume increases. Why volume increases? Alveoli is expanded. Why alveoli? I am telling you now in reverse. Why alveoli is expanded? Intrapleural pressure become more negative. So this more negative pressure suction, more negative pressure expands the alveoli. Why more negative pressure? Diaphragm contracts. That is the main thing. Contraction. Inspiration is active process. Diaphragm contracts. External intercostal muscle contracts. This both muscle contractions only increases the vertical diameter, transverse diameter, and anteroposterior diameter. So very simple actually. Now again, okay, how long the air comes? So this -1. So I will be keeping on breathing for normal inspiration. 500, 1000 ml, 1500 ml. No. Again, there is a check here. See how the physiology works. It's really very wonderful. So don't get confused. Actually, what I am telling only two things. High pressure to low pressure, volume and pressure inversely proportional. Even during exam, if mechanics of breathing comes, just understand these 2 points. Gas move from high pressure to low pressure, volume and pressure are inversely proportional. Then all these things are easy. No need to confuse. So now inspirations here. Intraalveolar pressure 0 at rest. So now we clearly understood during inspiration the pressure is decreased here by -1. So high pressure to low pressure. So for understanding 500 ml, which I will be discussing in later chapters, like lung volumes and capacities. So as this 500 ml now comes, now this is very clear. I have drawn here. At rest 0, when your intraalveolar pressure, IAP is intraalveolar pressure. When it is -1, the inspiration starts. So the inspiration of air starts when your intraalveolar pressure becomes negative, -1. So now imagine, I'm just here. Now because it is -1 intraalveolar pressure, high pressure to low pressure, from 760 to 759, I'm inhaling 100 ml, 200 ml. So once I reach 500 ml, what happens inside this alveoli? Air has reached. So as now imagine, at inspiration, 500 ml of air is inside this alveoli. So what happens? The air creates equilibrium. Are you able to understand? So the purpose is reached. What happens? This air is equilibrating with the alveoli. The air in the alveoli is equilibrating. Now what happens to the pressure? No more air wants to come in. Now what happens? Though no more air wants to come in, again the intraalveolar pressure becomes 0. Since air has come, the pressure is nullified otherwise. So what I can mean is, yeah, now next step. Yeah, this is -1. Air, this is because of expansion -1. Now what happens? Now what happens during expiration? Diaphragm is coming back to original position, recoiling. External intercostal muscle is also relaxing. So now what happens? As this comes above, after inspiration, what will happen to this volume? Yes, this volume decreases. So as the volume of thoracic during expiration, obviously compression upwards occurs. During inspiration, vertical diameter is increased. During expiration, I am going to breathe out air. So what happens? This diameter is decreased. So what will happen to the volume? The volume is decreased. Everything is reverse. As volume is decreased, what will happen to the pressure? Pressure is increased. So instead of -5, it may be -4 or -3. Yeah, now coming back to intraalveolar pressure. So as the pressure here is increased, this pressure is compressing the alveoli. Yes, so alveoli is compressed. There, during inspiration, alveoli is expanded, but here there is an increased positive pressure. I mean, from -5, during expiration it has become to -4 or -3. So this pressure is reflecting on this, and internal alveolar pressure may become +1 or 761 to make you understand. So this is resting pressure. I again repeat, internal pressure at rest is 0. During expiration, diaphragm comes back to its original pressure. Elastic recoil. Expiration is passive process. So no contraction of muscles. Whatever muscles contracted during inspiration comes back. Or elastic recoil of the lungs. You just remember elastic recoil of the lungs. So what happens? Because of coming up of diaphragm, the pressure is increased. So -4. As the pressure is increased, intraalveolar pressure is also increased, +1. So outside it is 760, here it is +1, 761. Now what will happen? Yeah, again gases move from high pressure to low pressure. So from 761 to change the direction. Yeah. So now this is high pressure, 761 to 760. So this is expiration, simple. So expiration is a passive process. And again, see the graph, IAP, intraalveolar pressure. At 0, no expiration occurs. At end of inspiration, it is 0. As the diaphragm and external intercostal muscle relax or elastic recoil of the lungs, pressure becomes, even it becomes positive air itself, +1. And again same thing, as the air goes out, what will happen to the intra-alveolar pressure? It again comes back to 0. So this is end of expiration. So this diagram is very, very important. So 0 at rest, as the inspiration it is -1. At the end of inspiration again it is 0. For expiration, intra-alveolar pressure is +1. That positive pressure only is pushing the air outward. And again, as the air comes down, as the air comes out, again there is equilibrium. So no pressure change is needed, and it again comes back to 0 at the end of expiration. This cycle keeps on going. 500 ml, -1. Outside, expiration, from 0 to +1. At the end of expiration, 0. So the cycle keeps on repeating, inspiration, expiration. And based upon this intra-alveolar pressure, and note it down, even during inspiration, expiration, your atmospheric pressure is always 0, that is 760. Atmospheric pressure is 0, whether you are inspiring or expiring. Intra-alveolar pressure only varies. Intra-pleural pressure also varies. That you have to be very, very clear. Whatever we discussed is normal inspiration, normal expiration, that is 500 ml. Note it down. For forced inspiration, I am inspiring 500 ml. All we discussed, what happens? I am inspiring more than 500 ml. For that, I have got some more muscles apart from diaphragm and external intercostal. Note it down. It is scalenus anterior, pectoral muscles, and the sternocleidomastoid muscle. All similar mechanism. They try to, like external intercostal muscle, they also are accessory muscles, or they can be called as accessory muscles of inspiration, which plays a main role in deep inspiration or forced inspiration. Scalenus, pectoral muscles, sternocleidomastoid muscles. Note it down. Again, same mechanism. The rib, for example, scalenus comes here, which tries to pull the rib outwards, and the sternocleidomastoid muscles is also somewhere here, which also tries to, sternocleidomastoid muscle from here it comes. This also tries to pull the rib outwards. Now coming to expiration, passive process which you know, note it down. Yes, for forced expiration, you can pause the video and tell which muscles will be involved for forced expiration. Air has to go out. Normal expiration is passive. Just a diaphragm comes back. Elastic recoil of the lungs, which is a property of the lung. For forced expiration, what could be the muscles which have to contract? Because forced expiration is active process. Active means muscles have to contract. So what could be the muscles which can push the air outwards? I gave the clue. Yeah, most of the abdominal muscles. Mainly rectus abdominal muscles, transverse abdominal muscles. Main muscle, please note it down, for forced inspiration, internal intercostal muscles. So external intercostal muscle is for normal inspiration. Again, the concept is, these are the two ribs. So see here. So external intercostal muscle is explained. From origin is from the upper rib, insertion to the lower lip. As the external intercostal muscle contracts, I like a bucket under the movement. The rib like this here. This is external intercostal muscle. Reverse. This is internal intercostal muscle. Internal intercostal muscle, maybe the origin will be from that below and insertion may be above. So this here, external intercostal muscle is this. Internal intercostal muscle is, the origin and insertion is other way around. So what will happen when internal intercostal muscle contracts? This is the movement. So this is upper rib, this is lower rib, this is internal intercostal muscle. So the movement will be like this. Or your transverse diameter is reduced. Diaphragm coming above, obviously vertical diameter is reduced. So note it down. For forced expiration like this, this is normal, no muscles involved, 500 ml. So when more than 500 ml I want to expire, I require internal intercostal muscles to contract. Most of the abdominal muscles, rectus abdominal, transverse abdominal muscles. Okay, now we saw about the muscles for forced inspiration, forced expiration. Now let us confuse the topic. For forced inspiration, what would be the pressure changes? Obviously intravalvular pressure is going to be negative, so that air comes from 760 to 759, but here forced inspiration is what? Yeah, instead of -1 it can be -2. Again here intrapleural pressure will be more negative, intraalveolar pressure will be more negative, so more air coming in. Instead of 500 ml, maybe 700, 800, whatever according to the pressure. So forced expiration means more positivity. So alveolar pressure more positivity means instead of -5, here it was -3 I wrote for normal expiration, but for forced expiration it will even be -2 or -1, like that. Intraalveolar pressure, normal expiration, intraalveolar pressure is equal to +1 for expiration. For forced expiration, yeah, intraalveolar pressure may be +2 also. So +2, imagine. So here it will be 762 and here it is 760. Before 761, 760, 1 millimeter difference is there, 500 ml is going out. 762, 760 +2. So +2 means more air is going to go out. That is forced expiration. And if you want, we can even calculate transthoracic pressure. The same formula. Transthoracic pressure means three pressures. Transpulmonary pressure is intraalveolar pressure minus intrapleural pressure. Transthoracic pressure means 2 minus 3. Intrapleural pressure minus atmospheric pressure. Respiratory pressure means alveolar pressure minus atmospheric pressure. Usually it is 0 at normal, because alveolar pressure at normal is 0, at resting lung is 0. So today in this video we discussed about muscles of inspiration, muscles of expiration, what are the volume changes that occurs during normal inspiration, normal expiration. A quick summary, this diagram will be very easy. At resting state 0, as the intrapleural pressure becomes negative, the alveolar are expanded, so more air is going to come in. As 500 ml air comes in, the air makes an equilibrium with alveoli, and so what will happen? The intrapleural pressure again comes back to 0, that is at the end of inspiration. Again during expiration, the normal passive process, elastic recoil, pressure starts increasing. Yeah, +1. At +1, 500 ml you might have expired. As you expire 500 ml, again the air is gone out. So again it comes back to equilibrium. The volume of air is gone. So it again comes back to equilibrium to 0. These are death of inspiration. So note it down. Intraalveolar pressure at rest. Please tell me the answer. 0, which we all know. Now pause the video and try to answer. Intraalveolar pressure at end of inspiration is 0, +1, -1. I again repeat the question. Intraalveolar pressure at end of inspiration is 0, +1, -1. Yes, the answer is 0 at the end of inspiration. 500 ml has gone in. So the answer is 0. Next question. Intraalveolar pressure at peak mid expiration is, or at the maximum expiration intraalveolar pressure is. Options: -1, +1, 0. Yeah, the answer is +1, because expiration is not completed. I am expiring. At the peak expiration it is +1. That +1 is only causing the air to go from 761 to 760. Final question. Intraalveolar pressure at the end of expiration is. Yes, the answer is 0. At the end of expiration 0, at rest 0, at the end of inspiration is 0. So this you should remember. In next class we will go on regarding the discussion of very important topic, compliance. Compliance means stretchability, the extent to which lungs can expand, and how surfactant plays an important role in reducing the surface tension as well as maintaining the compliance. So I hope today's video was very useful to you. We completed the mechanics of breathing. Previous class, at rest what happens to the pressure. Now during inspiration what happens to the pressure. During forced inspiration what happens to the pressure. Same expiration, forced expiration. So with this I will conclude today's class. If you have liked this video, please share to many of our friends, your college mates, other college mates, so that it will be useful for them. If you are yet to subscribe to my channel, you can subscribe to my channel, Dr. Sen Physiology, and press the bell button also for further notifications of the. As I told already, RS series we are continuing and we are going in a good flow. So next video, we will meet on next video on compliance and surfactant. Thank you.